Dimensional Analysis Video Notes, Part 3.
Go on, go to school. Go on, sit down. I'll be waiting for you when you get out. Ain't nobody gonna mess with you. Nobody.
Problem number 7. First thing I recognize in this problem is that she is jogging to the grocery store. Who jogs to the grocery store? No one jogs to the grocery store. But the second thing I recognize is the important math pieces of this problem, like the 3 units I've underlined. The first thing I'm going to look at is the 2 hours and 45 minutes of this problem. Now, I need to either convert it to hours or minutes alone. I can't have hours and minutes both in the conversion table as one unit. So I'm going to look at the other rates in the problem. The one underlined in yellow is 2 kilometers per hour. So it's already in hours. I'm going to convert it from minutes to hours. In order to do that, you just leave the 2 hours alone. So leave that part alone. It's 2 hours. We know there's 2 hours there. 45 minutes, though, has to be converted to some sort of decimal of hours. So in order to do that, I've set up our conversion table with 45 minutes as my beginning and hours as my end. I'm going to put 60 minutes on bottom and 1 hour on top. So my minutes cancel out, and I multiply 45 times 1 divided by 60, and I get 0.75 hours. Now this right here represents the minutes portion of the hours, so that has to be added with the 2 to give me the full amount of time. So really 2 hours and 45 minutes is the same thing as 2.75 hours. And that 2.75 hours is actually going to be the beginning point of my actual conversion table for the problem. Over here at the end, I have miles. Miles is what we want to end with. We want to know the distance from the grocery store to her original location. So I'm going to start adding in the other conversion ratios from the problem. The first one is the yellow up here, 2 kilometers per hour. So I'm going to put 2 kilometers on top and 1 hour on bottom, because it's 2 kilometers per hour, and that's going to cancel out hours for me. Now I have kilometers in my conversion table, and I'm still needing to go to miles. So there's a specific conversion ratio from kilometers to miles that we use. It's 1.609 kilometers is equal to 1 mile. And so once I put that in the conversion table, kilometers will cancel out, and now I can just multiply 2.75 times 2 divided by 1.609, and I can get my answer in miles. And so for our answer, we get rounded to the nearest thousandths place that the answer is 3.418 miles. So the grocery store is 3.418 miles away from the original location. Problem 8 and problem 9. In problem 8 and problem 9, it's not actually asking you to figure out a number or a numerical answer. It's actually asking you just about the units. So it's asking us if the radius is measured in centimeters, what is the unit of the entire area of this circle. So basically, I'm just going to replace the radius with centimeters and see what happens. A equals pi times centimeters squared. All right, pi is just a number, 3.1415, blah, 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 blah. It just goes on forever. All right, so it's an infinite number. Pi is an infinite number. It's just a number in the front of the centimeters, so therefore it's just a coefficient. So the actual unit of the area of the circle is just centimeters squared. That's what the area of a circle will be measured in if the radius was centimeters. Problem number 9 is pretty similar. You do have to know the volume of this rectangular prism, which is length times width times height. Just like in the problem previous, just like in problem 8, I ignored the number pi. I'm going to ignore all numbers in this example. So I'm going to ignore the 5, ignore the 7, ignore the 4. I don't really need those. All I need is the units, because that's all the question is asking me is what is the unit of the volume. So I'm just going to plug in the units. Volume equals length is measured in inches, so it looks like up here. Width is measured in inches, and height is measured in inches. So it looks like the unit of the volume is going to be inches times inches times inches, which is the same thing as inches cubed, or sometimes we call it cubic inches. But the unit of volume should be measured in cubic inches, and the unit of area over here in the circle should be measured in centimeters squared, or square centimeters. Michael Jackson, greatest entertainer of all time.
It's true.
Yeah, I know. So the first thing I need to do in this problem number 10, is actually identify the correct units. And so I did. I identified the important units in the problem, 700 inches and 80 feet. Those are the correct units for the length and the width of this sandbox for his monkey.
Good. That's good.
Yeah, so I put the 700 inches on the sides, I put the 80 feet on top and bottom, and the whole goal is to find the minimum perimeter in feet that the sandbox would have to be. So I need to find out what this perimeter of this object would be. But I got to find it in feet, so therefore these inches that I have on the sides have to be converted into feet before we can add up to get the perimeter. So if you look over here to the left, I've already set up the conversion table. My inches will cross out, and I'll just have feet left over, which is what I want. 700 times 1 divided by 2 ends up being 58.3 feet, where the 3 is repeating. So I've crossed out the inches and I've replaced it with the 58.3 feet that we found. And now my goal is to add up the entire perimeter of this object, which basically means add up all of the sides, 80, 58.3, 58.3, and 80. And then that will give me my minimum perimeter that the sandbox has to be.
Absolutely.
And so the minimum perimeter is 276.6 feet. And since I did this problem and figured this out for Michael Jackson, I think it would be a good idea if, he would loan me some money.
It's not a good idea. Money is the root of all evil.
Oh, okay. Well, thanks anyway, I guess. Problem number 11 is a challenging problem about the density of a metal called chromium. And it gives us the density in kilograms per cubic meters or meters cubed. And it wants us to find the density of that same metal in grams per centimeters cubed. So it's going to be a long conversion table. The first thing we need to recognize is that kilograms per meters cubed is the same thing as kilograms per meters times meters times meters. And I'm actually going to write it out like that because I think it helps with the visualization of what's actually happening in the problem. Whenever we cancel out units, it'll help make that more clear. So I'm starting with 7190 kilograms over meters, 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 and I'm ending up with grams per centimeters cubed. So I know I'm going to have to go from kilograms to grams and from meters to centimeters. So I set it up like this. I know that there are 1,000 grams in every kilogram. So now, since I have kilograms on top and bottom, I can cancel both of those out. So right now in my conversion table, I have grams over meters cubed, which is grams per meters cubed. But I need grams per centimeters cubed. So I'm going to have to convert from meters to centimeters. The only issue is I'm actually going to have to convert from meters to centimeters 3 different times in order for it to work out. Because I have to actually cancel out all 3 of the m's on bottom. I know that there's 100 centimeters in every meter. So that now that I have all 3 of those in the table, I can begin canceling out my units. Meter cancels out with meter. Meter cancels out with meter. Meter cancels out with meter. So now if you look at my conversion table, you should see grams as the only unit on top and 3 centimeters on bottom. Centimeters times centimeters times centimeters, which is centimeters cubed. So I have the conversion table set up correctly where I'll have grams per centimeters cubed as my answer. And after multiplying on top and dividing on bottom, I got 7.19 grams per centimeters cubed as my final answer.
Why'd you have to leave so soon?